Okay, let's start. Alright, so hello everyone and welcome to another science video lesson. And on this video lesson, we will going to talk about chemistry. Alright, so what part of chemistry? That is chemical reactions. As we all know, in chemistry, there's no chemistry without chemical reaction. Alright, so these chemical reactions are the highlights of what we will going to study here in chemistry. Now, since we are talking about chemical reaction, so today in this video lesson, we will going to study what are the different types of chemical reaction and how to balance them. Okay, so let's get right into it. Alright, so this is what the chemical reaction or the presentation that we will going to have in this video lesson. Alright, so what is a chemical equation? Alright, so what is a chemical reaction? So basically, in order to represent a chemical reaction, you need a chemical equation. Just like in math, alright? So just like in math, if you want to represent what is on your Cartesian plane, there is an equation that is appropriate on that. Alright, now if you want to solve, the area, the perimeter of your polygons, there is an equation on that. Alright, same thing with chemistry. Alright, so in order to represent what are these chemical reactions all about, so we represent them through chemical equation. Now, the chemical equation is it is a form of equation that contains your chemical formulas, alright, which reacts to each other and they form a certain product which has a new chemical formula, alright, so which is completely different from its previous or original form. Alright, so let's discover this one. Okay, so what is this chemical equation and chemical reaction? Alright. Alright, so what do we have here is this is the classification of what we will going to have today. Alright, so starting from chemical reaction, so what do we need to learn here? Now, under chemical reaction, there is a chemical equation and another chemical equation. So these are the two things that you need to know about chemical equation. Number one is balancing chemical equation. This is very, very important in chemical reaction. Alright, next, predicting products from reactant. Alright, so the other side is also chemical equation, but it talks about the different kinds of or types of chemical reaction. Alright, so we have here synthesis, decomposition, double displacement, single replacement, and combustion. So all of them, we will going to talk about that one here in this video lesson. Alright, so let's get started. By the way, the prerequisite for this one is you must know how to form chemical reaction. You must know how to name chemical reaction, form a chemical reaction. Alright, so you know the step-by-step process in making your chemical formula. Alright, so before entering this particular lesson, because if you don't know how to form a chemical formula, you will have a hard times relating with this one. Alright, so how do we describe chemical reaction? So these are the indications that a chemical reaction happened. Alright, so number one, there is a evolution of gas. Alright, so there's an evolution of heat, heat, light, or sound. Now, whenever you have a chemical reaction, there's an evolution of these three things that you have right here. Alright, so let me give you one thing. Example is the electrolysis. Alright, electrolysis of water. Now, if you want to separate water, from its certain atoms that makes up your water, alright, so and liberate this hydrogen. Okay, all you need to do here is to separate them using electrolysis. Now, if there's a sound on the test tube, okay, when you put a fire on the test tube and then it pops out, alright, it pops after putting some flame inside the test tube, then therefore you successfully liberated hydrogen. Alright, so these are some examples. Alright, in some cases, when sodium reacts with chlorine, there's light. Alright, there's light. And calcium carbonate, when it reacts to hydrochloric acid, there's a heat. And the next one is also gas. Alright, so there's a gas. Okay, now when you burn things, there is this product called gas. Okay, next one, formation of precipitate. So in a formation of precipitate, like the one that you have right here, all right, so when you mix two compounds together and they react with each other, a precipitate like the one that you see on the picture will likely to form. All right, so that is the formation of precipitate. Next is the color change. This is very, very important. All right, in a chemical change, all right, this is the difference between a chemical change and physical change. In physical change, you do not change the color. All right, you do not change the color of the material in order to say that it is a physical change. All right, there's no color change in physical change, but in chemical change, every time that you have your chemical reaction, there is always a color change. All right, so if the color of your product changes from its original, then therefore there's a chemical reaction happening on your experiment. All right, so that is your color change. Okay, next. Okay, so let me repeat it one more time. So number one is changing color. Okay, next, number two, change in odor, so production of gas. Next is just like what we have right here, so odor and production of gas. Next, release of energy like heat, sound, okay, something like that, light. Okay, and chemical reactions are difficult to reverse. All right, so this process is difficult to reverse. All right, so in some conditions, if the conditions are right, some of the chemical reactions can be reversed, but it takes a lot of resources to do that particular process. All right, so these are the signs of chemical reaction. All right, so let's go now to the next part. So, in order to depict the kind of reactants and products and the relative amounts in reaction, okay, so this is one example of a chemical equation. So what do we have right here? So we have aluminum and oxygen gas. All right, they likely to form aluminum oxide. Okay, so what do we have right here? Okay, so this is an aluminum. So you know already, you happen to see an aluminum foil. All right, so aluminum is used in making aircraft body. All right, also car bodies yan. So these are aluminum. Next, oxygen is in a form of gas. All right, so that is the gas that we use to breathe in. Okay, and aluminum oxide is the product when you combine aluminum and oxygen respectively. Now, that is the aluminum oxide. And it looks like this in a powder or in another form. Okay, that is the aluminum oxide. And we call this aluminum and oxygen as reactants. Alright, so we call them as reactants, where the otherwise is, we called it products. Okay, now, in a chemical equation, if you are doing this in a laboratory, you should include letters like this, alright, that indicates the state of matter of your reactants and products. For example, I have right here an aluminum which is in a solid form, and oxygen is in a gaseous form, and the product is in a solid form of aluminum oxide. So these letters stands for solid, liquid, and gas respectively. So these are the physical state of your compound before and after chemical reaction. Alright, now, these numbers that you have right here, is called, or are called, stoichiometric coefficient. Alright, so these are coefficients, so you don't need to include this one anymore. So we called it coefficients. Alright, so these are the highlights of what we will going to talk about in this video lesson. Alright, next one. Alright, so what do we have right here? Okay, so as we all know, aluminum reacts with oxygen, form aluminum oxide. And okay, So if you going to interpret this one, if you will going to interpret this one, it is not interpreted as 4 grams of aluminum and 3 grams of oxygen. Alright, so you don't interpret that way. Okay, so you don't interpret them that way. So instead, okay, so what does this equation means? What does it mean? How to read them? Alright, so it means that there are 4 aluminum atoms because it's just only the aluminum, and you have your 3 molecules, alright, of oxygen. So why is it molecule? Because molecule is part also of a compound. So this is a compound. So it consists of 2 atoms of oxygen. So that is why it is called molecules. And it has 3. Okay, so the coefficient there represents 3 molecules of oxygen. Yields, the arrow, 2 molecules of aluminum oxide. Alright, so in other words, alright, you can also call them as 4 aluminum moles, right? 4 moles of aluminum, the other way around, 3 moles of oxygen. Alright, so moles and molecules are different entities, guys. So moles and molecules are different entities. Moles are not abbreviation of molecules. So take note of that. Next, 2 moles of aluminum oxide. So basically, that's how you read them. Alright, that's how you read chemical equations. Not by mass. Alright, so they are not read as the one that you have right here. Okay. There you go. There you have it. Alright, so okay, so that will be a topic for another day, this smaller mass that we have right here. Okay. Okay. Now, because the same atoms are present in the reaction at the beginning and at the end of the products, the amount of matter in the system does not change. So it means that whatever entered in your reaction must end, alright, must be seen on your product. So in short, there's no molecule, or there's no atom that is left behind, or there's no atom that will enter your chemical reaction and be part of your product. The system must not change. And this particular statement is what the law of conservation of matter is all about. Alright, so that is the statement of the law of conservation of matter. So it tells us that in a chemical reaction, whatever the reactants is must be seen on your products. The system does not change. You cannot create matter nor destroy matter. That is the law of conservation of matter. Alright, so as like what I've said earlier, if there's 100%, alright, if there's 100% on your chemical reaction that entered as a reactant, then therefore it must be splitted on the same amount, 100%, but in different percentages of your reactant. Still 100%. Alright, so in an isolated system. Now, if your chemical reaction happen in a not so isolated system, then therefore there will be an external factor that might affect the chemical reaction. Okay, so that is the law of conservation of matter, and it was developed, or it was proposed by Anton Lavoisier. Alright, so he is the father of chemistry, and he notes that if matter cannot be created nor destroyed, then therefore all chemical reactions must be balanced. Alright, all chemical reaction must be balanced. So that no matter is created nor destroyed. That is what Anton Lavoisier said on this idea. Okay. Now the equation must be represent the known facts. Alright, so number 1, the equation must contain the correct formulas. This is the highlight here. Alright, you can form a chemical equation if you want to, but if it has an incorrect formula, if the equation has an incorrect formula, then therefore your equation is, there will be an error on your equation, all right? Especially the reactants and products. They should have a correct chemical formulas. That is why before you enter this one, I warned you that you should know first how to write chemical formulas. All right. And it must follow the law of conservation of mass respectively. Alright, so before you follow the law of conservation of mass, it must have a correct formulas. Alright, so next one. Okay, so just like Thanos, so the one that we have right here, just like what he said, perfectly balanced everything. Okay, so from unbalanced chemical reaction to a balanced chemical reaction. Alright, so before we proceed to the next phase of our topic, so let's take a look at this simulation coming from PHET. Okay, so this is the simulation coming from them. So I ask you to go to their website. Alright, so to visit their I'm asking you to visit their website to see all other simulations that can offer that they offer on this website. So if you would like to donate on their part, so please do so because it will help them develop more simulations in the future. Alright, so thank you for PHET for providing this simulation that I have right here. Okay, now if you want to know what is about how to balance chemical equation, you can go to this website, the one that I have right here. I will put this one on the description. Alright, I will put this link on the description of this video. Alright, so you can click this introduction or you can even play a game. Alright, you can even play a game after learning something from the or after studying the introduction. Alright, so in this case, you can have a balance beam that you have right here or a bar graph. Alright, so both you can have you can have one at a time. Alright, so let's have this balance beam just to see if the chemical reaction that we have right here is balanced. Alright, so let's get right into it. Okay, so we have NH3 and NH2 over there. Okay, so NH3, N2 and H2 rather. Alright, now how to balance this NH3 over here? Okay, so as you can see, there are 3 atoms of hydrogen. Alright, so there are 3 atoms of hydrogen and there are only 2 atoms here. Alright, so how do we balance this one out? Okay, now by putting a coefficient, alright, so when you click this one, there will be coefficient that will enter here. Alright, so let's start. Okay, so to balance this hydrogen out, I need 3. There you have it. So I have now 3 atoms. Okay, 3 molecules of hydrogen. 3 times 2, 6. So I have 6 atoms. Alright, I have 6 atoms. So 3. But the thing here is this one is not anymore balanced to the other side. Then therefore, let's take a look at the other reactant, which is the nitrogen. So on the nitrogen, we have 2 and just 1 here. So what I'm going to do here is I will put some 2 here to balance. So I have now 2 molecules of ammonia. Alright, so 2 molecules of ammonia coming from nitrogen gas and hydrogen gas over here. Now, so this one is just 1. You can put there 1. Okay, so I have 1 molecule of this one, but I have 2 atoms of nitrogen. Alright, so does the product also have 2 atoms of nitrogen? Yes. Alright, so I have 6 here of hydrogen, atoms of hydrogen. Does the product also has 6 atoms of hydrogen? Alright, so we have 1, 2, 3, 4, 5, and 6. So definitely there is 6 atoms of hydrogen on the other side. So therefore, if you take a look at this balance, it is perfectly balanced as all things should be. Alright, so if you put it in this way, the bar graph, you can see that the number of atoms of nitrogen is balanced with the number of atoms of nitrogen on the product side. And then your hydrogen here is also balanced on the product side. So therefore, that's how you balance your chemical reaction. So we have more of that in the Okay, in the next few slides. Alright, let's try separating water. Okay, so I have here two atoms. Alright, so two atoms of hydrogen. Alright, so it is balanced over here. It has two atoms. But the oxygen is not balanced. So I have two atoms on the product side. Alright, I have two atoms on the product side. And I have one atom on the reactant side. So what I'm going to do is I will just follow what is the subscript of this one. By the way, this is a subscript, this one. Alright, so I will just follow and then put it in under coefficient. Alright, so I have now two atoms of hydrogen. Alright, in the process. So I have now two atoms of hydrogen. 1, 2. And that is balanced over here. Alright, so just one over here. Just put it there, 1. So 1, 2. Alright, so oxygen is balanced. But the hydrogen, since we added 2 coefficient here, it will affect the number of atoms. So 2 times 2, that will be 4. So it is unbalanced with this one. So therefore, we must put another one here that correspond to the number of atoms here. So if this is 4, so we just add 2. 2 times 2 is 4. Alright, so we have now 4 hydrogen. So let's see, 1, 2, 1, 2. So we have 4. Then 2 oxygen, so 2. Alright, so that is this simulation. And I urge you to go to their website, or I suggest you go to their website and visit this simulation. Alright, so that is the simulation for balancing chemical equation. Let's go back to our presentation. Alright, so chemical equations. Now, in the chemical equations, there's what they call the reactants. These are substances that exist before chemical change. Alright, these are the ingredients. Alright, basically, these are the ingredients on your chemical reaction. Next one, we have products. Alright, the products is the new substance. Most of the time, they are on the right side. Okay? Products are new substances that are formed during the chemical reaction. This is the product of chemical change. Alright? This is the product of chemical change. So, most of them is on the right side. And the reactants is on the left side. Okay? So, now, in a chemical equation, alright, it always has this form. It always has this form, which is the reactants will yield to a product. Alright, not products will yield to reactants. No matter what kind of product there is, it is still a product. It is what it is. Alright, so the reactants it is what it is. Alright, so there you go. So this is the chemical equation. These are all things. Alright, all this picture that you have right here are all balanced. Alright, including the chemical equations that you have right here. No matter how hard it is, alright, no matter how hard it is, you must still balance this chemical equation to achieve the perfectly balanced nature. Alright, so if Thanos is very anxious enough in balancing chemical equation, alright, so we have here another one which is called the word equation. Word equation is the translation of your chemical equation. Alright, just like in math, alright, there's what they call your algebra. Alright, so twice the x, twice the y, thrice the x, thrice the y. Alright, so something like that. Now, in chemistry, the chemical equation is also translated to word equation. Alright, so it describes the chemical change using the names of the reactants and products, respectively. Alright, so let's have a sample problem here. Okay, so we have here the word equation. Alright, write the word equation for the reaction of methane of gas with oxygen gas to form carbon dioxide and water. So this is how it is written. Okay, the one that you have right here. So the reaction of methane gas with oxygen gas to form carbon dioxide and water. So this is how the way they look like. Alright, but this is a word equation. Alright, you cannot balance this. You cannot balance this word equation. You need to transform this one into a chemical equation before you balance this word equation. Alright, now you need the knowledge of forming or writing chemical formulas in order to do that. Alright, so let's transform this one to a chemical formula and balance it. Alright, so we have the reactants. Okay, there's no problem with the reactant. And we have the products. Alright, so products, because there are two of them. So we have carbon dioxide and water respectively. So we have it by CH4. Alright, so this is the methane. So methane is an alkane. So it contains a single bond. Alright, so methane is an alkane. So that is a hydrocarbon. Next one, oxygen. Oxygen, be careful with this one, guys. Oxygen exists always in nature in diatomic forms. Alright, together with nitrogen, fluorine, iodine, chlorine, something like that. Alright, so it always exists like that. So if you write here like this, it is wrong. Alright, so oxygen exists in diatomic form. Alright, next one. We have carbon dioxide. So from the word itself, carbon, one carbon and two oxides. Alright, so we have two oxygen. Okay, so carbon dioxide. And lastly, we have the water. So you know already the formula of water, H2O. Dihydrogen monoxide. Alright, now we need to balance them. Alright, as all things should be. There you have it. So this is the balanced form of this chemical formula that you have right here. Now, whenever you have the balanced form of the chemical formula, that is always correct. But if it looks like this is incorrect because it is not balanced. Alright, so take note of that one, guys. Alright, next one. Okay, so just like what we did on the simulation that you have earlier. Okay, so in this case, we have an unbalanced chemical reaction. Alright, now in order to balance this one, so we need to put some coefficient that will balance the reactants to the product. Alright, so there you have it. Okay, now by putting coefficient, like the number 2 that you have right here, we'll be able to balance everything on your chemical reaction. There you are. Okay, so that's the effect of this coefficient. Alright, as you can see, guys, we did not change the number of atoms or the subscript. Alright, because that is forbidden. Alright, you do not change this one, guys. You do not change this one, only the coefficient. Alright, so you do not change the number of atoms of each of the molecule because it will change the identity of the molecule. Alright, next one. I have right here a sodium and a chlorine, alright, and they will likely to form sodium chloride in the process. So, how many moles of sodium do we have right here? And how many moles of chlorine do we have right there? And how many moles will be formed? Alright, so we have how many sodium? So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so we have 10 moles of sodium. Alright, so how many moles of chlorine? So, we have okay, so chlorine exists in diatomic form, so it is 2 chloride. Alright, so 2 chlorine. Alright, so chloride gas. So we have 2 chlorine atoms that are combined. So we have 1, 2, 3, 4, 5. So we have 5 moles of chlorine, or 5 moles of chlorine compound or chlorine molecule. Alright, next one. We have NaCl. So how many NaCl, how many moles of NaCl are we going to form in this one? Okay, so we have, so we need one atom of sodium and a chlorine to form NaCl. So what do we have here? So we have 5 here and we have 10 over here. All right, so basically we can create how many moles of NaCl? Okay, so let's combine. 1, 2, 3, 4, 5, 6, 7. Alright, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so we have 10 moles of NaCl. I lost count on that. Alright, so it means that our equation is alright, the equation is unbalanced, but in this visualization, we need to balance the equation so that this visualization is somehow will make it correct. Alright? That will make this visualization correct. So how do we do that one? By just adding a coefficient here and a coefficient there, it will balance now your chemical equation. So if we put there the mole, alright, then we have 2 and 2 over here. So that is how you balance your chemical reaction. Okay. Let's what's the meaning of the chemical formula if you forgot it? All right, so H2O means this is understood as 1. All right, this is understood as 1. All right, so 1 H2O means 1 molecule of water. All right, 1 molecule of water. So it contains 2 atoms of hydrogen and 1 atom of oxygen. Whereas I have here 2 molecules of water, then you can now have 4 atoms of hydrogen and 2 atoms of oxygen. And if you increase that one, alright, if you make that one into a different compound like the one that I have right here, the hydrogen peroxide, so H2O2, but I have 1 molecule of that compound, therefore it stands for 2 atoms of hydrogen and 2 atoms of oxygen. Alright, so that is the meaning of the coefficient that you have right there. Alright, so next one. Now, let's go now to our highlight, which is the balancing equation. Alright, one in which the number of atoms of each element as a reactant is equal to the number of atoms of the element as the product. So that is the key definition of balance equation. The product must be equal to its reactant in terms of number of atoms, not by number of compounds, not by number of molecules, but number of atoms. Take note of that one, guys. Alright, so what is the relationship between conservation of mass and the fact that balance equation will always have the same number of atoms of each element on both sides of an equation? What is the relationship between conservation of mass? Alright? They are directly related. Alright, so they are directly related, guys, because in a conservation of mass, you talked about, alright, in there, you talked about that the number of atoms must be balanced, alright, matter is not created nor destroyed. So just like what we will going to do here, we will try to balance the number of atoms so that there will be no atoms left behind, alright, or there will be no atoms that will enter the chemical reaction out of nowhere. Alright, so that's the key idea here. Okay, so let's take a look at this one. Determine whether the equation below is balanced. So let's take a look. Okay, so there are 2 moles of this atom. Alright, so there are 2 atoms of this. Okay, so 2 moles of this atom. Okay, so on the other side, there is also 2 atoms of that. So it is balanced. Alright, let's take a look at H2. H2 has 2 here. Alright, 2 atoms. And there's 2 atoms here. And another one. So 2 plus 1, 3. So it is that balance because we have 3 hydrogen atoms here, whereas on the other side, we have 2. Alright, and oxygen. So we just have 1. Alright. Let me clarify that one. So 2 times this one. So I have 2. Alright, I have 2 atoms of this one, of this hydrogen. So making it 5. Alright, 5. 3 plus 2, 5. Rather 4. 2 plus 2, 4. Yeah, sorry for that. Next one. I have here the oxygen as 1. And I have here the oxygen as 2 times 1. That is 2. Alright, so there's an unbalanced number of oxygen. Now, we need to balance this one in order for it to have a correct chemical equation form. Alright, so this is the balance form of this one. By adding 2 as coefficient, 2 times 2 will have 4. Then 2 times 1, we have 2, plus 2, we have 4 hydrogen. That is balanced. Okay, the sodium is already balanced. So we have 2 over here, then we have 2 over there for the oxygen. Then therefore, the equation is completely balanced as all equation should be. Alright, so let's move on. Now, write the equation for each of the following chemical reaction. Write the correct formulas again. So take note of that one, of reactants and products. That is very, very important. And it must have the number or the correct amount of coefficient that makes the equation balance. The number of coefficient follows the law of conservation of mass talked about by, said by Anton Lavoisier. Okay, so that's the coefficient. Alright, so with these three in mind, let's have another examples. Okay, so let's have right here. Now, is this correct? Alright, so is this chemical equation correct? So let's see. Okay, so we have one oxygen here, one atom, and another atom of oxygen here, which is 2. 2 plus 1, that is 3, which is unbalanced with this one. Alright? Even though the nitrogen is balanced, but your oxygen atoms is not balanced, so therefore it is not balanced. So this equation is not balanced. Alright, how about this one? Alright, is this equation balanced? So we just remove the subscript on the first equation. Is this equation balanced? So let's see. Okay, let's see if this equation is balanced. So we have n, so balanced. We have 1, 2, and 2 over here. Although it is balanced, but it is forbidden to remove the subscript because there is no such thing as, alright, so all oxygen exists in diatomic forms. Alright, so take note that one, guys. All oxygen exists in diatomic form. So if you were going to use that one in a chemical reaction, alright, in a chemical equation, it must have this subscript of 2. Alright, so don't forget that one. Now, how about this one? Alright, is this balanced? Alright, definitely not balanced. Alright, why not balanced? It's because there's no such thing as fraction or decimal in balancing chemical equation. It must be whole number. Right? It must be whole number. Okay, so take note of that one. Whole number is used, not fraction or decimal. There's no such thing as 1/2 the oxygen atom. Alright? There's no such thing as 1/2 oxygen molecule or 3/4 oxygen molecules. There's no such thing as that. Okay. Now, how about this one? Okay, so that's it. Alright, so these are the 3 things that you should look forward in treating your chemical equation, guys. Alright, so next one. Okay. So what we have right here is the balance equation for this one, the nitrous oxide. Alright, so we have nitrous oxide and oxygen gas reacts to nitrogen dioxide. Okay, so that is your chemical reaction here. Now, the 2 on the left of your NO is your coefficient that will make the molecules balanced. All right, or the equation balanced to be exact. All right. So this is a multiplier just like what you did in algebra. So we have your FOIL method. So just multiply it right here, then multiply it right there, then there you go. All right. So this is 1, understood as 1. So 1 times 2, that is 2. All right. So this is 2 times 1. Then 2 times 2, that is 4. Alright, so the subscript, take note, the subscript, you cannot change them. Alright? The subscript tells you the number of atoms per molecule that you have right there. Okay. Now, these are the guidelines. So, in some cases, in some books, they use different guidelines. Alright. Now, you can start first with polyatomic ions. Alright? Number 2, okay, so as much as possible, sorry for that, if you will try to balance a chemical equation, it must be even numbers. Alright? So, in order for you not to be confused, it must be in even numbers. Alright? As much as possible. All answers, alright? All answers must possibly in even numbers. Alright? Okay. So, number 3 is number 3 is OHOH is somehow, all right, it is somehow different from the formula of pure water. All right, HOH is a hydroxide. This is a hydroxide, the one that you have right here, the magnesium hydroxide. It has a completely different formula on your water. All right, next one. Okay, now, next, number 4 is the single elements will go last in priority. Example, in this equation, I need 13 oxygen atoms. So how will I going to, what I'm going to do that? Alright, so just do the general equations that you have right here, then multiply everything by 2, then you get 13. Alright, you get 13. Okay, so that's how you balance chemical equation. But in other books, you can follow this one as well. Right? In other books, the first priority in balancing equation is the first priority is the metals. You must balance first all metals, followed by non-metals. Alright, so followed by non-metals, except for oxygen and hydrogen. Alright, and third one, and the third and last is balance the oxygen and hydrogen respectively. So, you can use this one or you can even use this one if you want to. So, either of which make you comfortable, alright, it doesn't matter, alright, which one do you want to use, as long that it will make you comfortable in answering chemical or balancing chemical equation. Alright, so there you have it. Okay, so let's predict. Alright, so let's predict the product of this chemical reaction that I have right here. Alright, so this is a double replacement reaction, and it should have a 2 products. Alright, it should have a 2 product. Okay, so the one that is given here has only 1 product. Okay, so what will happen here? Okay, so let's predict what is the product. You can pause the video if you want to. So, what is the product that you have right there? Okay, so the product should be ammonium phosphate plus magnesium hydroxide. So the product is magnesium phosphate, and the missing one, what is that? That is ammonium hydroxide, and it looks like this. Alright, so later I will just show you how it is done. Okay, so for now, the product is ammonium hydroxide. Now, this is not yet balanced. This is not yet balanced, guys. Alright, so in order to balance this one, let's try to answer, or let's try to balance this chemical reaction to make it correct. Okay, so let's go to my whiteboard. Alright, there you go. So, let's write down the formula. Okay, let's write down the formula. So, I have it right here. So, okay. So, let's write down that formula. Okay. So, we have here NH4. So, maybe we can... Alright, so we have here NH4. Then the parentheses, we have... it is the opposite. Okay, so there you go. So we have NH4, then parentheses, that is 3. Then we have PO4. There you go. Plus, alright, so magnesium hydroxide, MgOH. Then we have 2. Okay. Next, we have on the other side, there's the arrow. We have Mg3. Then we have PO4. 2. Alright, so plus NH4. Alright, OH. There you have it. There's no parenthesis on that. Okay. So, the question is how to balance this one. So let's use red for this one, and we divide the screen into 2. Alright, so let's write down all the metals. Alright, let's write down all the metals. Okay, so what are the metals here? So we have Mg. Okay, so aside from that, next one, the non-metals. So we have phosphorus. Alright, so we have nitrogen. And finally, we have oxygen and hydrogen, respectively. Alright, so let's count them. Okay, so there's one molecule, or there's one atom, rather. Alright, so there's one atom on this one, magnesium hydroxide reactant. Now, how many phosphorus? So there's only one atom. Alright, so do not include this one here. Alright, do not include this one. Alright, next one. How about nitrogen? How many? So, since this is in the parentheses, so we can multiply it by 3. So, 3 times 1, that is 3 atoms. Okay, so there you go. Next one. We have oxygen. So, we have 4 over here. 4 plus, okay, so 2 times 1, that is 2, or that will become 6. Alright, so we have 6, or simply, in order for us not to be confused. Alright, so, okay, so we have 4 on this side, okay, and we have 2 on this side. Okay, so that is total of 6. Alright, so next one. They have the hydrogen. We have 4 here times 3, that is 12, plus, okay, so we have 2 times 1, that is 2. Alright, so there you have it. Okay, so now, what is the on the other side? So let's put it, let's write it the same thing. So we have Mg, that is P, that is N. So notice how I arrange the elements. So metal first, non-metals, and oxygen and hydrogen on the last. Alright, so now, if you are an expert already, now you just practice this one all over and over again. Alright, you may not need to write this one anymore. Alright, you may not need to write this one anymore if you are well practiced for this one. Okay, so how many mgs? Alright, so we have 3. Okay, so next we have the phosphorus. So we have P, 1 here times 2. Then we have N, so just 1 over there. There you go, 1. And oxygen, 4 times 2, that is 8 on this side. Then plus, we just 1 over here. Alright, 1. Okay, how about the hydrogen? So there's none here. So we have over there, we have 4 plus 1. Alright, 4 plus 1, so that is 5. Alright. Now, how do we balance this one out? Okay. Now, let's try first the magnesium. Since it has 3 over here, alright, since it has 3 over there, so we can put something like this 3 here. Okay? So, to balance it out. So, let's put it right here. So, we have 3. Alright, so 3 times 1, that is, alright, so I will now put this one. So, that is 3. There you go. So, 3 times 1, 3. Alright, so 3. So, magnesium is now balanced with the magnesium on the other side. Alright, which is the product side. Next one. Okay, so since you have 3 here, that you have, so 3 times 2, because of this 2, 3 times 2, that will be 6. So, we have now your 6 oxygen. Alright, so you have your 6 oxygen here. Okay, so in total, why did I put that one there? Alright, so let me rewrite it one more time. Okay, this is the oxygen. So that is 3. 2 times 3, so the 3 there, over there. Alright, so next one. Okay, so we have now 3 times 2 plus 4, that is 6. That is 10, rather. So that is 10. Okay, so next one. We have 10 over here, so nothing is adjusted on the other side. Next one. Let's balance the phosphorus. Alright, so let's balance the phosphorus. So if you have 2 here, because of 2 times 1, 2. So let's put something here that will balance this phosphorus here to become 2. Alright? Now, once you put a coefficient here, it will affect everything that you have right here on this equation. So it will affect everything here. Alright? So let's see. So since we put some 2 here, so we have 2 times 3. Alright, so that will be 6. Okay, next one. 2 times, okay, so this is 12. 2 times 12. Alright, so 2 times 12, that is 24. Alright, so next one. 2 times 1, the phosphorus, that is 2. Alright, next one. 2 times 4, that is 8. Alright, so 2 there. Alright, so generally, how many do we have right here? So let's, okay, so this one is balanced already. So we have, okay, so we have 2. So we have 6. 4 times 2, that is 8. Alright, 8. Then we have this one, that, okay, so 4 times 2, 8. Then 2 times 3 is 6. That will be 14. Alright, on this side. Next one. How about the hydrogen? Okay, there's nothing, oh, I forgot this one. Okay, so 3 as well. 2 times 3. Alright, so 24 plus 6, that is 30. There you have. Okay, so that is the for the this is for the reactant side. Now let's go to the product side. Okay, so the Mg is, or the magnesium is balanced, and the phosphorus is also balanced. All we have now is this one. So this is not yet balanced. Alright, so what are we going to do here? If this has 6, so with this one. So with this one, so it should have 6 as well. So we have 6 times 1, that is 6. Alright, so it will affect everything that you have right here. It will affect. So we have now 6 times 4. Alright, 6 times 4, that is 20. 6 times 5 rather. Alright, 6 times 5 because of this one. 4 plus 1, that is 5. Alright, next one. How about the oxygen? Okay, so we have here 8 on this side. So we did not adjusted this one. We did not adjust this one. So we will not put something here. Okay, so 6. 1 times 6 is there. Okay, so 8 plus 6, that is 14. There you have it. Okay, so is it balanced? So nitrogen is balanced, yes. Oxygen is balanced, yes. Then hydrogen is balanced, so that is 30. Yes. Now, this is the balance equation for that one. So let's see if we are correct. Where's that? There you have it. Okay, so far we are correct. Alright, so it means this one is 1. Alright, so you don't need to put 1 there. Alright, just to emphasize 1. Okay, just leave it blank. It is understood as 1. Alright, so let's try this one. Alright, so let's name first. Okay, let's name first everything that you have right here. So we have aluminum chloride. Okay, aluminum chloride. Right, so next one, lithium carbonate. Okay, lithium carbonate. And this one is aluminum carbonate. Alright, next one is carbonate. And the last one is lithium chloride. Alright, so that is the name of these compounds that you see here in this example. Alright, so let's go to our whiteboard to answer this question that we have right here. Alright, so I will need another new whiteboard. Okay. Okay, let's write it down here. So we have AlCl3 plus Li2. Alright, CO3. There you have. And we have the arrow. On the other side, we have 2 CO3. The parentheses, don't forget 2. Rather 3. Alright. Next one, plus LiCl. There you go. Now, what is the balance equation for this one? Let's divide the screen again. Okay, so let's write down all metals. Alright, so all metals, so we have Al. Right, so we have Li. Alright, so next one, we have the non-metals, aside from oxygen and hydrogen. So we have chlorine, and we have carbon. Alright, then followed by oxygen. There you have it. Alright, so let's write it on the other side as well. So we have Al, aluminum, lithium, chlorine, carbon, and oxygen. There you go. Okay, so let's have this red one. Okay, let's count the number of atoms. So Al here is just 1. Alright, so Li, we have 2 over here. This one, 2. Okay, so we have chlorine. So we have 3. Alright, so 3. Next, we have carbon. Alright, you just have 1 carbon there. Right, next, we have oxygen. So 3 is over there, so we will put it 3. Alright, so these are the numbers on the reactant side. Next one, how about on the product side? Alright, so let's take a look. So we have 2 over here for aluminum. Let's have the lithium. So we have 1. Okay, so we have the chlorine. We just have 1 as well, this one. Alright, next one, we have the carbon. Alright, so the carbon is very tricky because it is on the parentheses. So we have 1 times 3. 1 times 3, that is 3. Alright, next one. The oxygen, it has 3 inside. So we have 3. Alright, we have 3 times 3, that is 9. Alright, gosh, that is so many. Okay, so how do we solve this one? Okay, let's start first. Let's take a look first at the aluminum. Okay, I will use the blue ball pen. Now, if your aluminum here has 2, alright, and you cannot change this subscript, and you cannot put subscript on the other side, only by just putting a coefficient will make it balance. Okay, are we clear on that? Alright, so let's recount it one more. Let's recount it once again. So we have 2 here. Okay. Let's not have first the answer. Alright, so we have 2 times 1, that is 2. So make it balance on this side. Okay, so they are already balanced. There you go. There you have it. Next one, the problem is chlorine. We put something here, it will affect this one. So this will become 2, that will be 6. Alright, so that will be 6. Right, so that's the only chlorine there. Alright, so it will be 6. So let's go to the other side. Okay, let's go to the next metal, which is the lithium. Now, the lithium here has 2. Alright, there's a subscript here. You cannot remove the subscript. You can't remove the subscript. And you cannot put a subscript on this side. Alright, you cannot put a subscript here. So what are you going to do? You just put there the coefficient. Alright? You just put there the coefficient. So, okay, so lithium 2. So, let's see. Okay, let's see what do we have right here. Okay, so 2. Okay, so we have 2 over here. Then, what do you have? Okay, 6. So, we have insufficient amount of chlorine. Alright, so we have an insufficient amount of chlorine here. Because if we put here 2, alright, if we put here 2, we will have insufficient number of chlorine. So, let's erase. There we go. Alright, so what are we going to put here? Alright, so since this has 6, right? Since this has 6, so let's put here 6. Alright, so let's put there 6. Okay, there's nothing wrong on that. Alright, so let's put it 6. So we have lithium 6. 6 times 1, that is 6. Then we have chlorine, which is 6 times 1 as well. We have 6. Alright, so we have 6 and 6 over there. So the chlorine is now balanced. Okay, now how about the lithium? So if you have 6 over here, what are you going to do here? So think of a multiple of 2 that will have the answer of 6. So that is 3. Alright, so lithium will have 3. 3 times 2, that is 6. So it is now balanced. Alright, this is now balanced. So, it will affect this one. So, your carbon, 3 times 1, we have 3. Alright. Next one, your oxygen, 3 times 3, that is 9. Alright, so we have 9 and we have 3. Now, should we adjust this one? So I think no. Alright, we will not adjust this anymore. We will not adjust this further. So it will make it balanced. Okay, so there you have it. So first thing is metal, followed by non-metal, then followed by oxygen and hydrogen respectively. So let's go back now to our point. So let's see if that is correct. Alright, so we are correct in providing the answer to that problem. Okay, let's continue. Okay, write the balance equation for the reaction between chlorine, sodium bromide to produce bromine and sodium chloride. Alright, so what do we have here? Okay, so write the balance equation for this one. Okay, so let's take a look. Okay, so as I've said last time, you should know first how to write a chemical formula. Alright, so sodium bromide. So how does it look like? Okay, so let's write first the complete formula before anything else. Okay, so sodium bromide, okay, plus chlorine. Alright, so chlorine yields to produce bromine and sodium chloride. Alright, so there you have it. Okay, chloride. There you go. That's it. Okay, now let's write the chemical formula and balance it. Alright, so what is sodium bromide? Alright, sodium is located on family number or group number 1. So it has plus 1. Okay, the bromine. Alright, so the bromine is located on group number 8. Alright, so it has negative 1. Alright, so group number 8. Number 7 rather. Alright, so it has missing electron. Alright, it has missing electron. So, okay, so if you want to combine this one, you just use the crisscross. Alright, so there you have it. So, the crisscross is, the formula for that one is NaBr. So, there you go. Plus, chlorine exists in gas or diatomic form. So, it should be written as this. Take note of that one. It doesn't exist the other way around. Alright, so, next one. Okay. Now, the bromine also exists in diatomic form, so it looks like this. Alright? Next one. The sodium chloride. So, how do we form sodium chloride? Sodium is located on group 1, so plus 1. And your chloride or chlorine is located on group 7, that is negative 1. So, just crisscross. Alright? You don't need to write the 1 anymore, so it looks like this. Alright, so we have now your chemical equation. Now, the problem is that is not balanced. Alright, so to balance it, let's take a look at this one. So since you have 2 here, so the metal is balanced. Alright, so the sodium, there's no problem. Alright, so since you have 2 here, okay. Okay, so let's write everything so that we will not be confused. Wait. We have here Na, Br, then Cl. Alright, so there you go. Now, what do we have here? Okay, now, the Na is number 1. The Na is 1 here, then the Br is also 1, then the Cl is 2. On the other side, the Na is 1, then the Br is 2, then the Cl is 1. Alright, so, since the Br here has 2, let's put some 2 here. Okay, so let's see if that will balance. Alright, so definitely it will balance. But, it affects the sodium. Alright, it affects the sodium. So we have 2 over there. Okay, now what are we going to do here? Now, we put also 2 on the other side. Okay, so that will change the amount of sodium atoms that you have on the product side. So we have 2. And, alright, so we have 2. Then, that is 2. And your chlorine will now have 2 because of this coefficient. So, we have 2. Alright? So, let's check if it is balanced. So we have 2 here, 2 there, 2 here, and 2 there. So the balanced form of this chemical reaction is 2NaBr plus Cl2Br2 plus 2NaCl. Alright, so okay, so with that, okay, this is how you balance your chemical reaction. Okay, so on the next video that we will have, the part 2 of this video will be all about the types of chemical reaction and some sample problems related to balancing chemical equation. Alright, so okay, so with that, I hope you did learn something on how to balance chemical equation in this video lesson. Now, just wait for the part 2. So, just wait for the part 2 and make sure that you are subscribed on my channel and you just hit the notification bell for that, for the uploading of that particular video. Okay, so like this video if you learned something, and put some comments in it, so it will help me a lot. Okay, so suggestion if you want to. Alright, so that ends up our video lesson today, and I hope you see each other on the next video lesson. Bye bye guys, peace out.